Next speaker is Arian Skoki, Research and Teaching Assistant at Faculty of Engineering, University of Rijeka. He will talk about unlocking the secrets of soccer performance and in-depth analysis of player physical fitness. The new framework that provides a more comprehensive understanding of player performance, helping coaches and managers gain valuable insights into how players respond to different game situations. It offers a more in-depth perspective than traditional metrics such as high-speed running and sprinting.
Thank you. Well, hello to you all. My name is Arian, as already I got introduced. So today's goal is to present you first 3 different data types that are used in football. I will call it football because we are in Europe. So I just put soccer in the title so everybody knows. The first data type is the event-driven data. So it's used for tactical analysis, and we will use it just for providing a context into this physical data that we're going to present next. So let's start by explaining what is the event-driven data. The data set that we're going to present first, it's from StatsBomb, a data provider. And the event data, you can imagine yourself like passes, tackles, shots that are made throughout the course of the match. And then how is it captured? So TV cameras are doing a broadcast. And you can see here the image on the left. What this polygon with blue, if I can, I don't have the laser, okay. So this polygon in blue is actually camera view site. And what camera captures, it represents in these little circles. These little circles are one team, which is in red, and the other team, which is in yellow. And then we have some events, maybe a shot, maybe a pass, or something. Here we have just a green arrow. We don't know yet what that is. So let me take you through a few frames of this data, and we're going to see then later what is the true representation of it. So it starts from top left, and then we'll proceed down there, then go on the right, and then to the top right. First situation in the top left, so again we see some red and yellow circles, which represent the positions X, Y axis of the players. And we have an event that is called ball recovery. So this team quickly regained possession after losing it. After that, this same player carries the ball forward, so it drives forward. In the third frame, it makes a pass to the player on the left. It could be a fullback, it could be a winger, we don't know yet. We just know who makes a pass. And then in the fourth frame, we know that this player got the ball. Let's see what happens next. Fifth frame, top left. This player drifts toward the box with the ball. Then in the sixth frame, makes a pass across the box. This pass reaches his teammate, which shoots first time at the goal. And we see in the eighth frame that the side flipped because it was an event of the other team, and it got a deflection. So does anybody have an idea of the outcome of this situation? Did it result in a goal, save, off target? Autogol maybe. Let's see if we can play this video that I was worried about. But if we can't play it, I will just describe the situation. No? Okay. So let's go back then, so it's easier for you. What happened actually here in the first frame? Modric recovered the ball after being tackled by Casemiro. The ball got to Vlasic, which carried the ball forward, passed it to Orsic here on the third frame, which then does his one-on-one regular, drifts inside and passes the ball to his teammate Petkovic, which shoot the first time. It hit a deflection and went into the goal. And Croatia went crazy after that moment. We all know everybody was celebrating. Another semifinals for a country with less than 4 million people. Second time in a row. It was a great accomplishment. But I saw that we had some Brazilian attenders here, so I know the feeling. We felt it in the semifinals, how it is to lose the game. So we will try to put this into the context by now presenting in the first and second chapter tracking and GPS data. So what is tracking data, what is GPS data, how we can calculate some metrics like the distance covered, etc. Then we're going to have a look at more in-depth analysis, not just an overview of 90 or 120 minutes, but can we zoom in what is happening minute by minute, because it provides more context. And then we're going to wrap up, see the benefits of both and what can be done in the future. So how is this distance measured? You can see in the paper or in the journalists are saying after a match, okay, this player covered 13 kilometers and it was a key to success of this team. So how is it measured? You have two types of data. So the first one, tracking data. It's captured with the cameras. You have to have at least 3 cameras installed into the stadium. And then the cameras can determine the position of the players and more or less accurately determine XY axis of that particular player. So they're capturing all the players, home team, away team, and also the ball. On the left, it's a similar representation. Maybe somebody played Football Manager, so this is the same visualization like Football Manager. And then on the other hand, you have GPS sensors. That is put on the player's vest, so they have to wear it, as you can see on the image on the right. And it captures only information about the players that are wearing the sensors. But it's a gold standard for data retrieval and measuring the physical performance of the players. Let's see how then this tracking data is calculated, how we can extract some additional metrics from these XY positions. So we have XY positions, and it's framed in, let's say, 50 milliseconds. So each 50 milliseconds, we know the position of the player. So we can see the change, and first of all, we need to smooth this kind of data because we can have a lot of, some distances and some measures are not that accurate. So we need to provide some filtering. On the left, unsmoothed data. On the right, smoothed data with some moving average or whatever is needed for you, for your particular use case, but moving average will do the job for you. And when we have this smoothed data, we just apply simple physics, accumulate this data, and we end up with something like that, where we can see exactly how our team performed, how the opponent team performed, how the substitutes performed. So we here have the distance covered by each of our players. And it's a valuable information, but usually we need more than just total distance. We can use metabolic power, so this is just to give an overview, some energy expenditure, so provides more context in a single metric. The paper for calculating that, if somebody is interested, is over there. And we have the regular ones, distance metrics, so we know the velocity in each of the zones. We can see how many meters they walked, jogged, or most importantly, high-speed running and sprinting, because when you are sprinting and doing high-intensity stuff, it's more likely that will lead to a goal. Now, the GPS data. GPS data is not only GPS. So it's a lot more than that. We have a accelerometer, gyroscope, and magnetometer inside of these sensors, which means that we can measure more accurately amount of distance in acceleration zones, deceleration zones. Maximal speed is more accurate. You can also measure impacts like tackles and jumps, but that is for, let's say, more expensive providers. The cheapest ones do not provide that. So we have the integration of all these sensors inside this small, like you can look at like that, the size of it, and it's pretty convenient to wear these sensors. Images again on the right. So how does this data from GPS sensors looks like? Here, this image on the left provides an overview of metabolic power events. You can imagine metabolic power events like, for example, sprinting or something that is high intensity acceleration, for example. And here in this example, it's clear that in the first half, you have a lot of these. It's very frequent. Then you have the halftime, and then in the second half, it's not that frequent. So either this player is not that adjusted to the tempo of the game, or maybe there were some VAR decisions, penalties, or some other breaks. We don't know what exactly happened in this match. But you see what can be measured with GPS sensors. Now, why is it measured? Why do coaches like to see the distance and how much they ran? Because they need to train, and they need to adjust their training according to what they perform in the matches. So you want to train like you perform in the matches. And then you, again, measure the same parameters: distance, high-speed running, sprint, velocity, metabolic power, etc. And here is more interesting, this thing on the right, where you can have the load and measure the load in each of the weeks, or the load through the microcycles of the same week. So probably the biggest load is when you play a match, and then you need some recovery period, then you need some, let's say, mediocre training, and then you have in the midweek, you have the training that is like the closest to a match, but it's still, I think, at most 70% of the match. And then you, again, lower intensity and you proceed to another match. Of course, this is not for all the players. This is for ones who play regularly. You have the players that are substitutes, so they need to recover. You don't want them to be unfit. And all this is measured on the team level and also on an individual level. So this week 1, week 2, week 3 might mean that this week 4 is a very important week for the team. Maybe it's qualifications for Champions League, or a cup final, something like that. So you want to really be in the peak form in the right moments of the season. Now, we saw how these metrics can be calculated on a 90-minute basis. And we know that, I don't know, somebody sprinted for 50 meters or for 200 meters, did a total distance of 13 kilometers, but that is just an overall case. What actually can happen inside is that the player runs for 70 minutes a lot, and then last 20 minutes, he's dead. He can't cope with the tempo. And we really want to see that through the data. Okay, now looking at this picture, let's imagine that you and me, we are not professional football players, and we need to perform a sprint. So we do 10-meter sprint, which lasts for 3 seconds. Then we do a rest of 20 seconds. After that, we perform a maximal sprint of 20 meters, and we rest for 3 seconds, and I ask you, okay, repeat that. Probably you will have trouble repeating that. Either you won't be able to repeat that, or you won't be able to repeat it at that intensity. So you won't be able to reach your maximal speed. So we would drop probably 90% in our performance because we are not professional football players. But professional football players are very fit, and their performance doesn't decrease by 90%. It's 10 to 20% at the end of the match, which can mean a huge difference on the end result. And this is an example of a player doing these high metabolic power events. So you can see that he did the first event, which lasts for 3 seconds. He did the second event, which was very high intensity, for 7 seconds, rested shortly, but the performance did not drop that significantly, like a little bit, and then perform another event with another decrease in performance, but it wasn't that huge amount. And now I'm going to present you a paper that we did 6 months ago. So you saw tracking data, you saw GPS data. This paper was done by using GPS data. And we split the match into the intervals of 5 minutes, because that was the lowest we could go. And then we wanted to extract what is happening exactly in one particular minute. So I need to give an overview. We have 5 minutes. And we also have this high-intensity event, so like sprinting. We exactly know when the sprint happened. So sprint lasts from the minute 1 to minute and 5 seconds. For 5 seconds, and that was the intensity of it. So we know exactly through the course of whole match when these events happened. And then we have an overall overview, so the distance covered, high-speed running, plus these high-intensity events. We have plenty of features, so we need to reduce the dimension. Of course, normalization is done before that. So we reduced the dimension by applying PCA, and then we did clustering with Kmeans. What we want to do with Kmeans, so the result end of the clusters is 3 clusters, and the hypothesis is that we can represent these 1 minutes with low, middle, and high intensity. So let's look next. So don't be scared about this table. I will briefly just explain the data that is used. So we have first part, that is this 5 minutes that is preceding the observed 1 minute period. So we need to account to that what is happening before the observed 1 minute period to have really the information that we can conclude, is it a low, middle, or high intensity period. We can just conclude on this basis on this 1 minute period. Then we have a 3 minute period before this 1 minute period, but we only concentrate on high intensity actions. And finally, at the end, we have 1 minute period that we are observing, and we want to only have a look at these high intensity actions. At the end, when we do this clustering, we get low, middle, and high intensity clusters. Just a brief explanation of these. On the right, it's high intensity column, and you can see that it's very black. So these values are the highest, and that is expected because it's a high intensity group. But we can see one outlier. So this energy thing over here, it's not the highest in the high intensity group, but in the low intensity group. And these features over here represent the 5 minute period that is preceding the observed 1 minute period. If we have a look at what is happening in this 1 minute period, on the top, in this low intensity group, we can see zeros. So we don't have any high intensity events in the low intensity group. And why is that? So repetitive high intensity results in a low intensity, which is the recovery period for football players. If we apply that, we end up with a plot on the left. So this is for one particular match of a particular player. And we can see that at the start of the match, he had plenty of these high-intensity repetition events, followed occasionally by low intensity. But as the match went by, so at the end of the match, this high intensity turned into middle intensity, and we had a bit more of low intensity. So his performance dropped a bit. Here's the paper that we did, so if you want to have a look, the QR code is here. And the image on the top right, it's accumulation of all the players that we have examined through the course of 90 minutes. So we want to see the percentage in each of these 5 minutes folds, how they are performing. And we can see at the start of the match, we have plenty of high intensity. But as the match goes by, the percentage of high intensity decreases, and the percentage of middle intensity takes their place. Low intensity also increases a bit, but this is, again, in line with what I said, that the performance of the football players drops by 10 to 20%, and that's why high intensity becomes middle intensity, which is just the values that are a bit lower than high intensity. So we have a look at these two types of data, tracking data and GPS data. So why would you use tracking data? So you have context. You know where is the ball. You know where is your opponent. You can calculate very frequently because the frequency rate of these data is very high compared to the GPS, where we have only 5-minute splitting rate. We can do it in 3 minutes. Some providers do it, but not less than that. GPS sensors, on the other hand, are cheaper because these systems with cameras cost hundreds of thousands of euros. This is like in a range of 2,000 to 3,000 euros per unit, but it can be even cheaper. GPS sensors are gold standard for calculating the physical metrics in football. So the error rate on the actually calculated metrics is less than in the tracking data, but tracking data also is a good estimate of the player's running performance. Also, we have with GPS additional metrics, which we can use, but also you have to be careful with these metrics because there are so many of the metrics, and really you can get lost in the forest of all the different data that you have. So the final verdict regarding which one is better, I would say that the combination of both is the key. So you have the GPS data for your trainings, for return to play after an injury, for example, to compare the data with the state before an injury, and you have the tracking data for analyzing matches. So tracking data is not that useful in training because you need to, again, have installed cameras on your training ground, which is additional cost. But for the matches, you can tweak your processing to match your data from the GPS sensors, and then you get the best from the both worlds. Let's return to our starting situation, starting context. And why is it important for this to examine it minute by minute? So we had a look at Oršić driving towards the box, and Danilo was closing him down. But before this situation happened, actually, Danilo took a sprint forward, headed the ball got to Croatian players, and the rest is history, as you know. The problem here is Brazil had a 1-0 lead. Brazil had an, let's say, half time in extra time. So they could adjust their tactics according to a result. They could adjust their tactics according to expenditure of the players. Of course, Brazilian manager did some substitutions. He introduced, so Danilo first played the left back, 116 minutes, and then moved to a right back. He introduced some midfielders. But maybe if he did have information regarding these players that played the whole match and were probably not that adjusted to cope with the tempo of the match, maybe he should have ensured to provide this information to his players and to keep more compact structure. We don't know, but maybe this goal could be stopped if the coach had that information. We are all grateful that he didn't have that information, and I would like you to leave, to end this presentation with this thought. Thank you.
Hi, thank you. Really great talk. Just about the normalization, if you could go a little bit deeper. What was the process and the data set? What did you exactly do?
So it was normalized by a player position. So we took like what is regular data on this player's position data, and then we normalized all the players in these playing positions. And then we use this data for PCA then later on.
Thank you.
One last question from my side. So I saw that you used Kmeans, and it has 3 cluster values.
Yes.
So
yes.
I would like to know that, and I also saw that you used a knee point to detect them. So was it the case that the 3 cluster value came from doing this knee point, or you already had the inference that I will have three values there?
So when we did it on less data, it was clear. An available method, it was very clear that it's 3 clusters. Later on, when we used the whole season, it wasn't that clear, but we stick with it because it's very easy to interpret it. And that is what we are trying to achieve. So we need to provide information to the coaches and to conditioning staff that are not that familiar with IT, the data, and all the stuff. So I think 3 clusters is the maximal that we can go.
Okay, thank you.
Hi, I think this was interesting in the end that you mentioned maybe if the coach had the data live, then, well, our players wouldn't score the goal. So the question about that is, okay, so how legit is that, do you think, and does it happen in practice? Because if you get live data, then it's not just sports, then you're doing team against team, but also it matters who has better data science team or maybe more money to pay that. So does this happen in practice now? And what do you think about that, actually? It's another thing to do it after the match, but completely different while playing, because then it's not just sports.
Yeah, so during the match, you might have some influence, but data science is coming more like from the American sports into Europe, and mainly in Premier League. So the Premier League clubs are hiring, even the championship clubs are hiring now data science departments. Before them, it was like few top clubs. I can name like City, Barcelona, and Ajax, which is not in their level, but by using data science, they are at their level. Now it's even getting popular in Serie A, but really a lot of clubs are not getting into it, especially our clubs, which might benefit a lot from it with not investing a lot of money, but are currently leaning on people's decision like it's traditionally done. So during the match, I think you can have some more context, but what is beneficial is to track your players over the long run and to see, even when you have youth academy, to track your players through the years, through the ranks, and to see some similarities to the players that you probably sold later on, to detect young talent. So it's used highly for acquiring players, for talented identification, and this is the thing where it's the easiest to make the difference. But through the course of the match, you also can have some influence, but I think more influence is off the field.
Hello, thank you for the very interesting presentation. Just to follow up on your thoughts, you said in the US, the Big Four actually are investing quite a lot of money, and sports analytics is actually really, really big. In the US, we in Europe are kind of lacking. Maybe football not, but all other sports are lacking in that department. How big of an impact do you think sports analytics has, and how do you see it will resolve in the future?
Thank you for the question. So, as I'm in this field, I hope that it will get very big, so I can earn a lot of money. But it's a very interesting field, and I think that sports is lacking objectivity. So it's, I don't know, I think that we should change this because I have the feeling. I mean, this is not a reasoning for making decisions that will impact and cost hundreds of millions of euros, or a couple of millions of euros if you are doing business in Croatia. So if the companies are basing their decisions on the data, why should sports clubs be any different?
What do you think is the relation between, let's say, coach's intuition, which is highly regarded in Europe, like the gods is, I don't know, Jose Mourinho or whoever, compared to the insights that data could give us? I mean, obviously, we value coaches' insights more, but what do you think the balance is between those two?
So coach's decision is very important because the data can't do everything, but the data can help them lower the cost of acquiring information. So they can have more information and they can base their decision on more data. So they can, I think, make better decisions than before. It will help, like we saw in a lot of talks today, it's a tool. It will help an expert to reach better performance.
Thank you.
Thank you, Arian.